You think you know what it was. You don't. The Saber-Tooth Tiger, one of the most recognized animals in prehistoric history, is also one of the most misunderstood. And the misunderstanding starts before you even think about the biology. It starts with the name. Saber-Tooth Tiger is wrong. It was not a tiger. It was not closely related to tigers. The animal most people picture, Smilodon fatalis, split from the ancestors of modern lions and tigers over 20 million years ago. Calling it a tiger is like calling a dolphin a fish. The shape is familiar. The relationship isn't there. Its real name is Smilodon. And the real animal was unlike anything walking the earth today. You have seen it your whole life. The curved fangs, the muscular shoulders, the snarl frozen in museum dioramas and movie posters, the logo of an NFL team. That image is everywhere, and it is wrong in almost every direction that matters. Start with the fangs, because everyone starts with the fangs, and everyone gets them wrong in the same direction. When people imagine the fangs, they imagine weapons for holding, for gripping, for the long sustained bite a lion uses to suffocate prey. That image makes sense. It is how every big cat alive today kills. Clamp down, hold, wait. Smilodon's fangs were not built for that. They were 7 inches long, curved, laterally compressed, flat like a blade, not round like a spike. Under lateral stress, the kind generated by a struggling animal twisting and pulling, they would snap. They were not designed to hold something that was fighting back. For over a century, this was treated as a paradox. The most famous weapon in prehistoric history appeared to be structurally fragile. Scientists argued about it for generations. The fossil record eventually answered the question, and the answer changed everything. Those fangs were not for holding, they were for killing. Instantly, precisely, with one motion. To understand how, you need to understand what Smilodon actually was, because the body tells you everything. Forget the lean cheetah, forget the long-limbed lion built for the open chase. Smilodon was built differently. Stocky, massively muscular through the shoulders and forelimbs, low to the ground, wide-chested, short tail. Its limbs were shorter and more robust than any modern big cat. In body plan, it was closer to a bear than a tiger. That tells you immediately this was not a pursuit predator. Modern cats that chase prey are aerodynamic compromises. Light enough to accelerate, long enough to cover ground. Smilodon sacrificed all of that for something else entirely. Power. Its forelimb muscles were extraordinary. Studies of the skeleton show muscle attachment points far larger than any living cat of comparable size. Its forearms could generate force that would dwarf a modern lion's. This was an animal built to ambush, to wrestle, to pin. The claws were semi-retractable, good for gripping, not for climbing, made for holding something down. The spine was rigid, less flexible than a modern cat's. Modern cats generate speed through spinal undulation. The back flexes and extends like a spring with each stride. Smilodon's back didn't work that way. It was built for stability under load, for bracing, for the moment when something large was beneath it and needed to stay there. Now the fangs make sense. Smilodon's jaw could open to nearly 120 degrees. A modern lion manages 65, almost twice as wide. That gape wasn't for eating, it was for clearance. 7-inch fangs need to pass below the plane of the lower jaw before they can contact prey. The animal had to drop its jaw almost vertically just to bring the teeth into striking position. The muscles driving that strike were not jaw-closing muscles. Smilodon's bite force was actually weaker than a modern lion's. What it had instead were enormous neck muscles. muscles that pulled the head downward with tremendous force. The killing motion was not a clamp, it was a plunge. Head driving down, fangs punching into soft tissue, the throat, the underside of the neck. With the combined force of the neck, the shoulders, and the full weight of the animal driving from above. If the strike landed correctly, it severed blood vessels and the trachea simultaneously. The prey was dead before it could struggle enough to snap the teeth. One strike, precisely placed, over. It is a killing method with no parallel in any predator alive today. A solution so specific, so refined, that it took millions of years to evolve and left no descendants. But the fangs are only part of what everyone gets wrong. In the Brea Tar Pits in Los Angeles, there is a record that spans 50,000 years. Animals that came to drink from what appeared to be a shallow pool became trapped in the asphalt beneath. Over tens of thousands of years they sank, layer by layer preserved. Over 1 million bones have been recovered. Among them, more Smilodon specimens than any other large predator at the site. More than dire wolves. More than American lions. More Smilodon by a significant margin than anything else. For years this was a mystery. Why were so many saber-tooths dying in tar pits? The answer changed everything we thought we knew about these animals. They were coming to the aid of other saber-tooths that had gotten trapped. Many of the Smilodon bones from La Brea show severe injuries. Broken limbs, fractured vertebrae, crushed shoulders, wounds that for a lone predator would be a death sentence. But those injuries had healed. The bone had remodeled. The animal had lived for months, possibly years, after the injury. A 400-pound ambush predator with a broken leg cannot hunt, cannot chase, cannot kill. Without help, it starves. These animals were fed, cared for by others of their kind. This is what drew so many Smilodon to the tar pits. A large prey animal, a mammoth, a bison, would become trapped. Drawn by the noise and distress, predators gathered. Some saber-tooths got trapped trying to reach the prey, others came to help. More got trapped. The tar pits didn't just preserve the animals. They preserved evidence of social behaviour in a predator everyone assumed was solitary. Smilodon lived in groups, shared food, looked after injured members. This changes the entire picture, because an ambush predator that hunts alone takes very different prey than one that coordinates. Social hunting changes everything. The size of prey you can target, the strategy you use, the world you dominate. And Smilodon was living in a world full of megafauna. Ice Age North America was, in terms of large animal biomass, comparable to the Serengeti. Mammoths, mastodons, giant bison, ground sloths the size of elephants. Smilodon was at the top of that world. For nearly 2 million years it ruled the Americas, north and south, across grasslands and forests and the edges of glaciers. It was not struggling. It was not a transitional animal caught between eras. It was one of the most successful predators the Americas had ever produced. And then, in roughly 1,000 years, it was gone. The last Smilodon died approximately 10,000 years ago. 10,000 years sounds like ancient history. It isn't. 10,000 years ago, humans were farming. The first cities were being born. And while that civilization was taking its first steps, the last saber-tooth was dying. The question of why has never been fully answered. The climate changed. The Ice Age ended. The grasslands that had supported the megafauna for millions of years transformed. The prey Smilodon depended on was disappearing. But Smilodon had survived every previous warming period. For 3 million years it had lived through ice ages and interglacials. What was different this time? And then there are the humans. Modern humans arrived in North America around 15,000 years ago. The extinctions track almost exactly with the human colonization front moving southward. The megafauna had never encountered a predator that hunted with spears, that killed strategically, that didn't follow the rules the animals had evolved to expect. So which was it? Climate. Humans. Or both at once? The honest answer is nobody knows. The debate is ongoing. Every explanation has evidence. Every explanation has problems. What we know is that Smilodon survived everything this planet produced for 2 million years. It was not failing. It was not weakening. It was, right up until the end, one of the most successful predators the Americas had ever seen. There is a bone in the Brea collection that stops researchers cold. It belongs to a Smilodon female. Adult. Found with a lower spine so badly degenerated it would have caused constant pain. Severe arthritis in multiple joints. One forelimb with a healed fracture so serious that veterinarians examining the cast estimated she had limited use of that leg for the rest of her life. She lived for years in that condition. She didn't starve. She didn't get left behind. Somewhere in the same ground where Los Angeles now stands, a group of saber-tooths looked after one of their own, brought food, protected her, kept her alive far past the point where she could have survived alone. This is the detail that changes how you see Smilodon. Not the fangs, not the kill technique, not the ambush strategy, the care. We call it a monster. We put it on football helmets. We give it villain roles in animated films. We use its image to represent pure ferocity, pure aggression, pure danger. But the bones show something else. An animal that perfected a killing technique with no parallel in the living world. A social animal that looked after its wounded, a predator so precisely built for its world that when that world disappeared, it had no answer for what came next. Smilodon didn't fail. The world failed it. The bones remember all of it, and what they tell us is not the story of a monster. It is the story of something far stranger, far harder to reduce to a single image, something we were wrong about, almost completely.